In this lesson, we're going to solve a system of equations by graphing. So the first equation is y is equal to 2x minus 3, and the second one is negative 2 over 3x plus 5. So what you want to do is you want to graph the two equations, and you want to find out where the point of intersection is. That's going to be the solution. But let's put some marks on the graph first. Let's go up to 5 on the y-axis. And let's do the same for the x-axis. The advantage of drawing a big graph is you can clearly see where the solution is going to be. If you draw a graph with the marks closely spaced to each other, it might be difficult to see the answer. So the bigger the graph, the better it's going to be. Now each of these equations is in slope-intercept form. So starting with the first equation, we can see that m, the slope is 2, and the y-intercept is negative 3. So we need to go down at least 3 units. So for the first equation, the y-intercept is negative 3, that's going to be the first point. To find the next point, use the slope. The slope is 2. Slope is rise over run, so you have to go up 2 units and travel 1 unit to the right. That will take us to the next point, which is 1 comma negative 1. Now let's do it again. Let's go up 2 over 1. So that's going to take us to the point 2 comma 1. And then if we go up 2 over 1, we're going to be at 3 comma 3. Up 2 over 1, then 4, 5. And that's enough for this graph. And my lines are not perfectly straight, but let's do that again. You get the picture. Now let's graph the second equation. The y-intercept is 5. So we're going to start at a y value of 5. The slope is negative 2 over 3. So the rise is negative 2. The run is positive 3. So starting from the first point, we need to travel 3 units to the right. That's the run. And then we need to go down 2 units. So that will take us to the point 3 comma 3, which we could see it's the point of intersection. But let's continue graphing it. Now we need to go 3 to the right, down 2, but we're out of space for that. So let's just use these 2 points. And so that's going to be the graph of the second line. So the point of intersection is 3 comma 3. So therefore, that's the solution to the equation. Now let's check it. Now let's solve this by substitution. Let's replace y with 2x minus 3. So therefore 2x minus 3 is equal to negative 2 over 3x plus 5. And let's get rid of the fraction by multiplying everything by 3. So 2x times 3, that's equal to 6x. Negative 3 times 3 is negative 9. Now what is negative 2 over 3 times 3? Well, if we write it out, 3 is the same as 3 over 1. You can cancel the 3 and you'll get negative 2. If you don't see it that way, you can multiply across. Negative 2 times 3 is negative 6. And 3 times 1 is 3. Negative 6 divided by 3 is negative 2. So you get the same answer, whether if you cancel or if you multiply across. So this is just going to be negative 2x. 5 times 3 is 15. Now let's add 9 to both sides, and let's add 2x to both sides. 6x plus 2x is 8x. 15 plus 9 is 24. 24 divided by 8 is 3. Now let's plug that into this equation. 2 times 3 minus 3. 2 times 3 is 6. 6 minus 3 is 3. So y equals 3. So therefore, the answer is indeed 3, 3, which is the point of intersection between these two graphs.